Okay, so today we will solve GET 2023 mathematics question from linear algebra. So this is a question number 34. So this is 1 mark question. What this is saying, consider R4 with the inner product. So xy is the inner product, it is defined xi yi summation run from I equals to 1 to 4, where x is this vector in R4 and y is this vector in R4. And what is M? M is a subspace which is given this, and M perp, this is called the orthogonal complement of M. Then we have to find the dimension of the M perp. It will be what? Okay, so let's see. So this is the NPTEL reference in order to solving this problem. Okay, let's start. So what is, so inner product space, so this is the on R4, right? On R4 we have two vector x, which is x1 x2 x3 x4, and y is another vector y1 y2 y3 y4. So an inner product, so this is a map from B cross B to R4 cross R4 to R. So how this is defined? So this is basically a map from R4 cross R4 to R. So how this is defined? xy is, we have just the sum I equals to 1 to 4 xi yi, right? So basically x1 y1 plus x2 y2 plus x3 y3 plus x4 y4. So there are some property that this is symmetric in both variable, this is linear in both variable. Okay, and this is positive definite, means if vector is non-zero, then v is non-zero, then inner product v with v is strictly positive. So you can check that all this property will be satisfied for this inner product. So this is standard. So this is the inner product on R4. Okay, and what is given, that M is a subspace of R4. It is given that x1 equals to x3. So this is subspace given x1 x2 x3 x4 belongs to R4 such that x1 equals to x3, right? You can easily check that this is a subspace for subspace of R4. So let's find what will be the dimension of M, right? So as x1 equals to x3, let's put it there, x1 x2 x1 and x4, right? Where this x1 x2 and x4 all are real number. So this you can then write x1 1 0 1 0 plus x2 0 1 0 0 plus x4 0 0 0 1, right? So let call this is v1 to be 1 0 1 0, v2 let me calling it 0 1 0 0, and v3 0 0 0 1. And this is easy to check that all v1 v2 v3 all three are linearly independent. Note v1 v2 v3 are linearly independent. Right. So M is basically therefore a span of these three vectors, right? And these are linearly independent. So as M is basically span of, means finite linear combination of these three, right? v1 v2 v3. So which implies dimension of M is 3. right? So we have find out the dimension of M, which is 3. We have to find the dimension of the orthogonal complement of it. So what is orthogonal complement? How it is defined? So let me write out orthogonal complement. So this is defined, this is a concept on inner product space only, right? So let V be an inner product space and let for any set we can define orthogonal complement. For any set S, the orthogonal complement of S. So this is the definition. Orthogonal complement of S denoted by, this is denoted by S part by this notation, which is so S part this contain all x in this space V such that x inner product y is 0 for all y in S. So this is called the orthogonal complement. One can easily check that this S perp is always a vector subspace of B, whether S is a subspace of V or not, right? So this is one important observation of this S perp. So here we have to find the dimension of M perp. So okay. So this is okay. So M perp, similarly M is this vector subspace. So M perp will be like this. M perp will be all such x in R4 such that x inner product y is 0 for all y in M, right? So we have to find the dimension of this subspace M perp, because this is automatically a subspace. What we have said, that M perp will always be a subspace of the vector space. So this is a subspace of R4. Now let us write down another result. So it is saying if W be a subspace of an inner product space. So this is finite dimensional I am taking. Finite dimensional. W be finite dimensional subspace of an inner product space. V, then we can write V equals to W direct sum W perp, right? And So direct sum means this is saying that W intersection W per as singleton, and this is, and dimension of V is dimension of W plus dimension of W perp, right? Okay, let me write it properly. W be a finite dimensional subspace of an inner product space B, then B can be written as W direct sum W perp, and dimension of B will be dimension of W plus dimension of W perp. Okay, we will use this result to prove our the dimension of what will be the dimension of M perp, right? So therefore what will be the dimension of M perp? So therefore dimension of M perp will be dimension of what is V here. So as M is a subspace of R4, so dimension of R4 minus dimension of M. So dimension of R4 is 4, and dimension of M3 we have found out that this is 3. So dimension of M is 3, so we have got dimension of M perp is 1. Therefore dimension of M perp is equals to, this is 1. Okay.